Alright guys, so this lecture is on unit conversions. Now this is something that you've probably covered already in one way, shape, or form, most likely in your chemistry class. In your chemistry class it might be called, it might have been called dimensional analysis. However, in physics we use dimensional analysis for a slightly different thing, which we will get to later in the course. But the main idea behind unit conversions is that we're going to convert from one unit to another using these things called conversion factors. Now, why would we want to do this? Well, for instance, in physics, a lot of the equations that we use require us to use constants or well-known values, and these constants or well-known values have specific values and they're based on units. For instance, the acceleration due to gravity at the surface of the Earth is 9.80 meters per second squared. So if you're given a problem where maybe the distance is given in centimeters or kilometers, or your time is given in minutes, then you're going to need to convert between different units in order to solve the problem correctly. Because if you put, if you just put numbers in and you skip the units, and the units don't agree with each other, then you will get an incorrect answer. So that's what this is all about, and this is why you have to learn it. Now, as I said, the main kind of gimmick with unit conversions is the use of conversion factors. And the reason why this works and why it's so neat is that a conversion factor is really just a ratio of two quantities that is equal to 1. Okay? So for instance, I want to have a conversion factor that will allow me to go from inches to feet. And this is a very simple example. What I'll do is I'll put 12 inches on the top of my conversion factor and 1 foot on the bottom. And the idea is that 12 inches is equal to 1 foot. And as you guys learned in math class, when you have a ratio where the top and bottom are equal to each other, that ratio is equal to 1. So anything we multiply by this conversion factor of 12 inches over 1 foot or 1 foot over 12 inches, the answer we get will be equivalent to what we started with. Okay, and that's true for no matter how many conversion factors we multiply by. This will be true as well. So to start off with a simple example, as far as how this is done, say we want to go from feet to inches, and we want to use this conversion factor that I just showed you. What you do is you start with the quantity that you want to change. So just write that first, and you multiply that by your conversion factor. So in this case, we want to cancel out feet, and we want to go to inches. Okay, so we want to go from feet, and we want to convert that to inches. So I'll put feet on the bottom of my conversion factor. I'll put inches on top. Now I know that this is a fairly simple example. You guys very well may know the answer already, but I just want to show you the technique, kind of the mechanism we use in order, to convert one quantity to another, and for when you get a quantity that you don't know the conversion so well. So write your units first. Feet in this case goes on the bottom, inches goes on top, and we know that 1 foot is equivalent to 12 inches. The units cancel out. Always, 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 always write your units after your numbers so you can see how things cancel out. And we get 3 times 12, which is 36 inches. And because we multiply 3 feet by a ratio that's essentially equal to 1, the answer we get is equivalent to that 3 feet that we started with. In this case, it is 36 inches. Okay. Another example. Say we want to go from micrometers, and this is micro, kind of that funny looking U is micro. We want to go from micrometers to actual meters. To do this, you need to know what the prefix micro means. And in fact, there's a lot of metric prefixes that you guys need to memorize. The list is shown here. Please copy them down, in your class notes, commit them to memory, and I'll show you in a little bit why that's going to be so important. So the first prefix you guys have to memorize is tera. The symbol given for tera is big T, so wherever you see big T before kind of a base unit, then that means that you multiply the base unit times 1 times 10 to the 12th. So the symbol means this conversion factor 1 times 10 to the 12th. Giga is 1 times 10 to the 9th with the symbol big G. Mega, capital M, 1 times 10 to the 6th. Kilo, little k, 1 times 10 to the 3rd. Centi, which you guys are familiar with probably through centimeter, has a conversion factor 1 times 10 to the minus 2. Milli, small m, 1 times 10 to the minus 3. Micro is this funny looking Greek mu here, and we've kind of run out of m's. We use capital M for mega, we use small m for milli, so now we have to use the Greek m, mu. That's 1 times 10 to the minus 6. We will need that for the conversion we're doing. The other ones you guys are responsible for knowing. Nano, small n, 1 times 10 to the minus 9th. Pico, small p, 1 times 10 to the minus 12th. And femto, small f, 1 times 10 to the minus 15th. So you guys are responsible for knowing the prefixes from tera all the way down to femto. Okay, so going back to our conversion, we want to go from micrometers to meters, and I want to convert 5 micrometers, and we'll convert that to meters. So what I'm going to do is once again put the unit that you want to convert on the bottom, put the unit that you want to convert to on the top, and so that we'll have micrometers on the bottom, meters on the top. Now, the advice I always give to students, and this is where the payoff of memorizing this prefixes really is to put a 1 in front of the unit that has the prefix. So in this case, micrometers or micrometer, that has the prefix, so you put a 1 in your conversion factor in front of that unit. And then, as we saw in the other table, this micro means literally 1 times 10 to the minus 16th. This and this are equivalent. So I will replace this micro with 1 times 10 to the minus 6 on top, and then the micrometers cancel out. I'm left with meters, which is what I want, and I get 5.0 times 10 to the minus 6 meters. Okay, that will only work if you know your conversion factors. So again, please memorize geometric prefixes. What if we need to convert between two prefixes, two units that have prefixes, maybe picoseconds to kiloseconds? Now I'm going to start with 20 picoseconds, and my advice to you is don't try to go between two units with a prefix. In other words, don't put picosecond on the bottom and put kilosecond on top. Put picosecond on the bottom and get rid of that prefix first. So go from picoseconds to seconds. Then in the next step, make it a two-step process, convert from seconds to kiloseconds. Okay. So again, I've arranged these so that the units cancel out the way I need them to. Picoseconds will cancel out, seconds will cancel out. Okay, and we'll get kiloseconds in the end. Now also, we put a 1 in front of the unit that has the prefix. Pico means 1 times 10 to the minus 12th. I know that because I've memorized my prefixes. And 1 kilosecond. Kilo is 1 times 10 to the third. And if you multiply all that out, you punch it out in your calculator, what you would get is 2.00 times 10 to the minus 14th kiloseconds. Okay, so just to check, and this is always good to do a check, if I have 20 picoseconds, I'm converting to kiloseconds, it should be less than 20. Okay, kiloseconds is a larger unit of time than a picosecond is, so I should have fewer kiloseconds than I did picoseconds, and indeed I do. So always go back and check your answer to see if it makes sense for you. Okay, so that's how to go between two units where they both have prefixes. Something else that will come up is you'll have to convert between ratios. So kilometers per hour going to meters per second, for instance. Now, very often, you may be given this in another form where you have this slash here. I encourage you guys, when you write this on a piece of paper, to write it so that one unit is above the other unit. Instead of using the slash, do it that way because it's going to be harder to mess up, as far as what units on top and what units on the bottom if you do that. So I'm going to start with 70 kilometers per hour, and I'm going to convert that to meters per second. So what you do is you decide which unit you want to convert first. It doesn't matter which one you choose, but I'm going to choose hours. So since hours is on the bottom here, I'm going to put hours on top, and I'm going to put seconds on the bottom. Now, one common mistake students make is they say there's 60 seconds in an hour. I know you know that that's not right, but they kind of do it mindlessly. 1 hour actually has 3,600 seconds. You could very easily, go from hours to minutes to seconds, but that's, equivalent to what it is. So this first conversion factor converts from hours to seconds for me. Then, with the hours taken care of, I now go to the kilometers. 1 kilometer is equivalent to 1,000 meter, 1 times 10 to the third meters. And now the kilometers, are changed. So now I have seconds on the bottom, I have meters on top. That's what I want. And I get 19.4 meters per second. Okay, so once again, when you have a ratio of 2 units, write it so that 1 unit's above the other unit and just convert 1 unit at a time to get the correct answer. The last type of unit that you guys are going to see will be a unit that has a prefix that's raised to some power. So, for instance, pounds per square inch, which is the unit of pressure. In physics, we're going to convert that to kilograms per square meter. Okay, and atmospheric pressure at sea level is around 15 pounds per square inch. And so I would want, if I were working a problem, I would want to convert that to kilograms per meter squared. To do that, just as we did with the ratio prefixes, I'm going to change one prefix at a time. So I'm going to start with pounds. There's 2.2 pounds per kilogram. Okay, so that first conversion factor gets me kilograms. Now we have the inches squared, and this is where you have to be careful. Essentially treat it so that there isn't a power there. So I'm going to go first from inches to centimeters, then centimeters to meters. So I'm going to have 1 inch on the top. I'm going to have 2.54 centimeters on the bottom. That's the equivalency between inches and centimeters. Now, because that inches is squared, you need to make sure that you square this whole conversion factor. Okay, don't simply write a square next to these units, because then you're going to forget to square the number. You're going to forget to square this whole conversion factor, and you're going to get an incorrect answer. So make sure you square the whole conversion factor if the unit that you're trying to change is also squared. If it's cubed, you cube the conversion factor, okay, and so on and so forth. So now I've converted from inches per inch squared to per centimeter squared. I want per meter squared. So now the next step is I'm going to say that there's 100 centimeters in 1 meter, but again, my centimeters are squared, so I square the whole conversion factor. Okay, you do that, you multiply everything through, multiply all the top numbers together, divide by all the bottom numbers, multiply together, you get 1.1 times 10 to the 4th, sorry about that, kilograms per meter squared. And that is how you do conversion factors.